First one I want to do in section 11.2 is number 3. So if you look at practice problem number 3, that's going to be our first one that we look at together. So it says for each problem, directions say, for each problem, sketch the area bounded by the equations and revolve it around the x-axis. Find the volume for the resulting solid formed by this revolution. Leave your answer in terms of pi. Okay, so he wants pi answers. Cool. So you shouldn't necessarily, for a lot of these, need to have any type of graphing calculator to do them, hopefully. So think about what this looks like from back in our days of pre-calc. It's an x-squared graph. It's a parabola. It's unhappy because it's negative. That means it's going to be upside down. And the 4 means it's raised up 4. 1, 2, 3, 4. Here it is. All right, there's the vertex coming down this way. And there is my unhappy parabola. Now I'm taking the area bounded by it and the x-axis. So that's this area right in here. And I'm also only going between where x is greater than or equal to 0 and where y equals 0, which means I'm above the x-axis to the right of the origin. X values are positive. So this is my original shaded bounded area. Now what I want to do with that is revolve it around this x-axis. Well, if I were to do that visually, it's going to come down like this. And now it's this whole thing. All right, there's some important places in the midst of this. So one important place, if I'm looking at this, is where does it start and where does it end? Which let's make our representative rectangle. I'm going to put it right in the middle here. Your representative rectangle is always perpendicular to what you're revolving around. Let me say that again because it's really important. The representative rectangle is always going to be perpendicular to what you're revolving around. All right, so the second thing that's going to be important to you after you draw your representative rectangle is figuring out where your bounds are going to be. Now your bounds are along the x-axis because that's what you're revolving around. So those two coordinates at the edges of your area there that you have, those are going to be significant to you. So let's think about where that is. So if this is, you know that this one here is 0. This one is x equals 0. But the question is, what's that second one? What's the one on the right? And so the way that you get that is you want to know where it crosses the x-axis. So you're going to take 0, set it equal to 4 minus x squared, and solve that out. That's going to be help for your bounds. You can't set up the integral without the bounds. All right, so you get x squared equals 4, x equals plus or minus 2. Well, obviously from our picture, this picture, right, this part right here is x equals 2. The negative 2 would be on the other side. We don't care about that. That's not part of our bounded area. Okay, so the question is then, what's the radius? Because remember, we're working on the area, taking the integral of an area of a circle, which is pi r squared. So what's the radius? The radius is coming from your representative rectangle. Well, the top of your rectangle hits the parabola, 4 minus x squared. The bottom hits 0. So the radius of each of these circles is whatever that rectangle length is, and in our case, that's 4 minus x squared. And so let's take and set up the integral. So my volume of revolution is going to be the integral going from 0 to 2 of, pi in the front, don't forget pi in the front, pi r squared, pi, and then my r squared is the inside part, 4 minus x squared squared. All right, so we'll try doing this one by hand. If I were to square this out, so I've got the pi and the integral I'm not ready to substitute in yet. I'm going to square this. So 4 squared is 16. 4x squared and another 4x squared gives me a minus 8x squared. and then plus x to the fourth. Now I did that kind of fast. All I did was FOIL. So if I were to f of b minus f of a, this whole hot mess, I have the pi on the outside. If I take an antiderivative of 16, I'm at 16x. If I take an antiderivative of 8x squared, it's going to be minus 8x cubed over 3. And then it's a plus. X to the fourth becomes x to the fifth over 5. And now I'm going to evaluate from 0 to 2. Which really I only have to evaluate the 2, because when I plug a 0 in, I'm going to get 0, so it makes life a little bit easier. So really plugging a 2 in. I still have the pi that's skating along out front. Plug a 2 in, I get 32. Plug a 2 in, I get 8 times 8 is 64 thirds. Plug a 2 in, 2 to the fifth is 32, so this is plus 32 fifths. Oh my goodness, are we done yet? Do you have calculators? Can you do it in your head? Take a second. Or I'll be like the video when he says pause, pause the video. Here's the hope. 256 pi over 15. Do I have any takers on that? Anybody else agree? You guys are giving me a whole lot of nothing.
Yeah. Thanks.
Thank you. I need you. Okay. That's number 3. There's like a beginning problem, kind of getting you thinking about this stuff. Next one I want to look at is number 6. Now number 6 is not quite so easy, right? Because you've got, at least to graph, the square root of the sine of x. Like we know what the sine of x looks like, but when I take the square root of that, what the heck is that? So let me give you a picture of what this guy is. If you were to take your calculator and graph it, here's what you would get. Shocking, right? And so it's still the same directions. They want you to revolve it around the x-axis. So if this is my part that I've got, and I revolve it around the x-axis, it's going to kind of end up looking like a football. So I revolve it around, it comes down here like this, and then now this is my whole deal. And so thinking of my representative rectangle, perpendicular to the x-axis, because that's what I'm revolving around, there are some coordinates that are going to be significant to me because of the bounds. Let me show you, Abby, the x equals pi thing. So if I look at this, the coordinates that are going to be important to me are this guy right here that's on the left. Well, obviously that's at the origin.
Is that the other point, the x equals pi? Would that be the other point?
It is, actually, and that's exactly right. It turns out that this coordinate right here is actually x equals pi. It comes down at pi right there. Now think about that for a second. If I take the sine of pi, think about where pi is, right? Pi is the coordinate -1, 0. Sine is the y value, so it's really the square root of 0. And the square root of 0 is 0, which makes sense why that would be an x-intercept, right? Because that's where your x would be 0. So yeah, that's just telling you where you're knocking this thing off, where your bounds are. So it's kind of helping you out a little bit, but Anyway, you've gotten that even if you set it equal to 0. So either way. I think we have all we need to set it up. The question is, what's the radius? Well, the radius is the top of my rectangle, and that's the square root of the sine of x. Minus the bottom, but the bottom's 0. So there's my radius. So I'm going to set up my volume. My volume is pi. Don't forget pi. And then the bounds are going between 0 and pi. And that is for my radius squared. Square root of sine of x squared with respect to x. Well, what's the sine of x squared if I take the square root? The square root of the sine of x squared is just a sine of x. So that's kind of nice. So I got pi going between 0 and 2, really of just the sine of x with respect to x. What is the antiderivative of sine of x? Abby's guess is negative cosine. Is she right? Yeah, good. Okay, so good thinking. We still have pi on the outside. Keep Mr. Pi along. Of negative cosine of x. And that would be going between 0 and 2. I'm going to grab my calc because.
Miss Winter?
Yeah.
Why is it 0 and 2? I thought it was 0
Oh,
and
sorry,
pi,
pi.
right?
That makes me better. I knew something. That's why I was grabbing my calculator. I'm like, wait a minute. This doesn't see. Thank you. See, I need you. You need to be with me. Okay, cool. That makes me feel a little bit better. Okay. I have a pi on the outside. I have a negative cosine of pi minus a negative cosine of 0. So I'm going to say plus cosine of 0. Let's see what we got. If I'm at pi, my coordinate is negative 1, 0. Negative 1 is the cosine. Negative negative 1 makes it a positive 1. So here's pi. This is a 1. Did you catch all that? If I'm at 0, the coordinate is 1, 0. Cosine's the x. Oh, look at that. 1 plus 1 is 2. And my answer is 2 pi. Now I'm going to stop for a second.
Yeah, can you keep that there for 1 second?
I can absolutely. I want you to digest that for a moment. And Seal, you caught my 2 as well. Thank you. All right. Let's at least start the setup for number 10. That's the next one and last one that I wanted to try to do. We'll see where we can get to in the midst of 5 minutes. All right, this one now changes the directions, and it says, same instructions as above, but revolve it around the y-axis. Leave your answer in terms of pi. Now, if you're revolving around the y-axis, there's a couple things to consider. First thing is you have to have your equations in terms of x. X equals something. You saw that in the last section with area between curves. So the first thing I know I'm going to have to do is take this and solve it so that it's x equals. So let me do that. I don't like the square root. I'm going to square both sides. I'm going to swing things lefty-righty so that I can keep that x being positive. That means I'm going to turn him over here to the left. And I'm going to bring the y squared to the right. And then I don't want what x squared is, I want what x is. So x equals the square root of 9 minus y squared. All right, then I'm going to take and draw the picture. And for the sake of time, I will tell you that this is a semicircle going like this. The square root of 9 minus x squared. Where here is... Yeah, go on.
We're doing plus or minus or no?
We are not going to do plus or minus because it turns out we're going to revolve this thing around the y-axis. So it's going to... It's not going to be a plus or minus for these guys. I know that's kind of confusing. When do you plus or minus? When don't you? Because this part was just a positive part, we're going to keep this part the positive part.
Okay.
All right, so you're going where x is greater than 0 or equal to, and you're going right here. You're going to take, right, x is greater than 0. So that when I revolve it around the y-axis, you actually are getting the other side of this thing. You're getting this part over here. Now here's your representative rectangle. Again, you're perpendicular to what you're revolving around. So here is your representative rectangle. It's going horizontal now, perpendicular to the y-axis. And you're right, Abby, I should not have drawn this other part of it yet because that's the revolved part. So you got that, you caught that too. Okay, so let's see. If I take this thing and set up what my r is, I've got to figure out the radius. The radius comes from right minus left, from your representative rectangle. Well, it hits on the curve. Well, the curve is, remember we're using this guy, 9 minus y squared, square root of that. And so, my bounds are going, the bounds start here, look at the shaded part, right? Starts at 0, goes to 3. So my volume is going to be pi, bounds going between 0 and 3, of the radius squared, square root of 9 minus y squared, squared, with respect to y. Now when I square the square root, life is wonderful. I end up 0 to 3 of just a 9 minus y squared with respect to y. And this one's relatively easy to get the antiderivative. You're going to have 9y minus y cubed over 3, and then plug in your 3. I know we're short on time, so I will tell you your answer should be 18 pi.
Can I have your attention, please? If you haven't started already, please make sure you're cleaning your desk for the next class. Thank you.
Oh my goodness. All right. So the bound 0 to 3, comes from the information they gave you to start with. Your x values had to be greater than or equal to 0, and you're stopping at the y-axis with this thing and stopping at the x-axis. So the bounds kind of come from the fact that it's just this portion. This was the portion that was the original part bounded by the graph, by the parameters they gave you. And then, so you're only using the 0 and 3 part. It comes to this negative 3 when it gets revolved around that axis. But that isn't part of how you set the integral up. The integral comes from the original parameters that they give you. Oh, and by the way, I probably am showing you wrong with my pen here. If I'm in terms of y with this thing, then it's the y values. These are the 0 and 3s that you're looking at, not these ways. It's a 0 and 3 this way. All right, questions, issues, problems? We're going to finish more examples. Your task is, let me go back to our original schedule for the day. I know you got to go. For Tuesday, you're doing 1 through 10. So by Tuesday, remember Monday you're off. Wednesday we meet in class at 9:30. We're going to go and do examples then. And then I'll see you again on Thursday at 9:09. So for today, I guess the biggest thing is I'll see you again on Wednesday at 9:30, but email me if you've got questions on anything, all right? Have a lovely day and weekend.
This winter,
Yeah.
would you be able to hang
Yes,
hang on for
I can absolutely. Give me 1 second, Sairaj, and I'm staying on. I will be there in 1 second. Oh, you're good. I just wanted to mute myself before I. Yes,
Fourth grade?
I am good. They are actually going to be doing a review worksheet.
Okay.
So I actually was able to put music on the other day. So they could. It was pretty cool, and then I would check in with them every bit.
Yeah.
Yeah, it was kind of fun. Anyway, I'm good. I don't need anything.
I need some more reading.
Yeah. Thanks, Mary. Okay. I just had somebody came to the door, so I just wanted to answer them. So what is up, my friend Sairaj?
I'm sorry, Miss Winter. I was muted.
Yeah, I
So
think it was
did
from my end. Yeah, go on.
I did my mastery check. I sent you actually like a notebook picture so you can like see like my work
Yeah,
and stuff.
yeah.
Would you be able to take a look?
Yes. I can.
Check.
I'm writing myself my list of things I need to do. And I wrote myself a note to do something and I don't remember what, like I see my note, but I don't remember what it means. That's not good. All right, Sairaj, you are on my list to check your mastery check.
Thank you, Miss Winter.
You're very welcome. I will do that.
And if I have any questions, I'll email you.
Perfect.
Thank you.
All right, have a good day.
You too.
See ya.
See ya.